everybody in. If you're having trouble finding a seat, it's good to see a packed house here for the deploying SharePoint farms on Windows Azure. So my name is Paul Stubbs. I'm a architect on the Windows Azure Center of Excellence team. We're a small group of guys that go around worldwide and we talk to customers and build large-scale Azure implementations, including SharePoint and so on and so forth. And so one of the areas I've really been focusing on from my background in SharePoint is how can we deploy SharePoint farms to Windows Azure, and how can we build SharePoint farms, and how can we build, develop, and test and staging farms in Windows Azure, and so on and so forth. First, let me ask you a few questions and to decide whether Windows Azure is the right place for you. Currently, does your SharePoint farm live in a world-class data center? The investment that the Azure team is doing and the advancements in the technology they're using are really amazing. And you can see in this photo here, we have this model of containers. And containers are just shipping containers full of servers. They get one from a vendor, HP, Dell, or whoever, and they come in on a big truck and they plug it in, and they now have another 2,000 servers installed, right? And when a few servers go bad, they unplug it and send it back, and they do it. So the scale and the efficiency that we have in our data centers is really amazing. Next question is, does your SharePoint farm have global scale? Right? Global is the new scale today. And so are you able to scale SharePoint to not only size, but to reach customers at a global level? Do you have data centers in Asia? Do you have data centers in Europe? And do you have data centers in the US? And how much does that cost, and how can you reach those customers? So scale is not always about how big something is, but what the reach is, what the latency is, and what the experience is for users. And according to this, does your SharePoint farm have global presence and reach? Right? Is it easy to reach those customers in the locales that they're at? So if you think about some of these questions, we think about what does it mean to be a SharePoint farm in today's environment. A lot of times, your data centers that you have running in your own company may not meet these needs. And so think about, as you decide to migrate from SharePoint 2003 or 2007 or 2010 and decide to move to a new platform, what are some of the criteria, what are some of the characteristics that you want to have for your new platform? So today in the agenda, what we're going to do is we're going to take a journey down through kind of how we would progress through building SharePoint farms. We're first going to talk a little bit about developer farms. So what does it mean as a developer to quickly set up a test farm that I can run and do some build some apps on, or do some development. And then we'll talk about production farms and what's involved with automating that process so that you can push a button, walk away, and come back and have a full SharePoint farm running in Windows Azure. And at the end, what we'll do is wrap up with costing. So how do I figure out how much it's going to cost me, and how do I tell my boss, this is great, it's going to cost more or less or the same or whatever. And so we'll look at some scenarios at the end, and I'll show you how to do that. Okay, so here we have the cloud continuum model. How many people were in the last talk that Corey and I did on SharePoint? A few? Okay, good. So I won't try to overlap too much here. So the cloud continuum is this concept where maybe you're on-premise today in the bottom left, and you have the most control. You can fiddle with every bit. You can set every policy. You control everything. But with that control also comes the efficiency and the cost of having that control. And so you pay a price for that control. If we look at the other end of the scale, which is Office 365, software as a service model, you give up a little bit of control, but you gain an immense amount of efficiency, both in terms of cost and in terms of operations and management and time. So ultimately, the goal when you're thinking about moving you should first say, how do I move to Office 365? Because that's the future. That's the future direction of SharePoint, and that's really a place that will save you a lot of time and money. But we know people have legacy code. We know there are scenarios that aren't right for Office 365 yet. So we have this sort of middle ground, kind of a stepping stone on the way to Office 365. The ability to run your own SharePoint farms hosted in Windows Azure virtual machines. And that's the piece we're going to talk about today. So you still have a lot of control in that environment, but you also give up some of the costs that are associated with full control. So it's kind of a middle ground both in terms of control and in terms of cost. So the first thing is, what kind of workloads should you be looking at when you think about moving your SharePoint farm to Windows Azure? Well, one of the first ones is FIS, or SharePoint for Internet Sites. FIS is a great example of something you can't do today in Office 365. And you could stand up your own SharePoint farm and run a FIS solution. Kind of the sweet spot we see today, and even more importantly because today Windows Azure virtual machines are still in preview mode, which means they're not in production. There's no SLA today for them. You do get a 33% price break during preview mode, but we're in preview mode today. So the second option of building developer testing and staging farms is actually very attractive to customers, and we see a lot of people doing this. Because, yes, there's no SLA, but it's just a dev farm or a test farm, so if it goes up or down, it's not a crisis. So this is really a great spot, especially today until we go to GA for doing this. Also, hybrid applications are really interesting. How do you build applications that span tiers, if you will? So I can put a SharePoint farm, or I can put a workload from a SharePoint farm in Windows Azure virtual machines, but I may still connect back to my sites on premise, or I may still connect back to SAP in my data center, right? Or I may reach out and connect to Office 365, or I may reach out and build an application or an app in Windows Azure. So these hybrid scenarios are very interesting, at least for the foreseeable future. And then another scenario which is very interesting is disaster recovery. Today, if you have a disaster recovery farm set up for SharePoint, you in essence have a copy of the hardware that you have running in production. So you have twice the cost to provide DR capabilities for SharePoint. But imagine if you had your SharePoint DR farm set up in Windows Azure. Windows Azure is cloud, so we have the capabilities and characteristics of infinite scalability, or quick scalability, or quick scale up, or quick scale down. And so you can imagine you have a farm, if you have it in a hot standby, maybe you have a few servers up and running, and if something happens, you can quickly add more servers as the load flips over from your on-prem to your disaster recovery site. Or you could even have it in a cold state where your farm's sitting out there and you're not paying anything for it, and within a few minutes of a disaster, you could turn it on and all the VMs come up and running in Windows Azure. So these kind of scenarios are very interesting for people to provide disaster recovery. Some of the migration considerations. So what do I need to think about if I'm going to move my on-premise farm to Windows Azure? Well, software requirements. Do you have licenses, and are those third-party licenses licensed to run in a cloud-hosted environment such as Windows Azure? Are the applications or software that you're running dependent upon hardware? Do they expect to have a GPU? Do they expect to have multiple network cards? Do they expect to have broadcast network capabilities? All of those things which are not available today in Windows Azure. So there's a short list of things that you need to think about when you decide to move your SharePoint farm into Windows Azure that you have to think about. So the three of these things is really interesting. It becomes a very short list of requirements. So the takeaway is that it generally just works. So pretty much how you think about running your SharePoint farm today on premise should be the way that you think about running your SharePoint farm in the cloud. And there are really a couple of ways that you can Alrighty then. So remember, when you're filling out your evals, I had nothing to do with this. Yeah, exactly. So do you want to try to talk over this, or do you want to wait? Talk over this? So there's really two approaches you can do here in this environment, right? One is you can build your virtual machines on-premise. You may have those already. And then you just copy them up into Windows Azure storage, just like you would copy any file. The second approach is to actually build the virtual machines in the cloud, which means file new virtual machine, pick Windows Server, and then install SharePoint on that Windows Server, exactly like you would do on-premise. How many people are familiar with the virtual machines and Windows Azure infrastructure as a service capabilities? So maybe half. So just to quickly reiterate, we have this concept of storage or storage accounts you can sign up for. Storage accounts can hold files. VHDs are the files that we care about. We can create a virtual network. A virtual network can contain many cloud services. A cloud service can contain many virtual machines. So this is sort of the container model, if you will. Virtual machines within a cloud service can freely talk amongst themselves over any ports and any protocols. Virtual machines and from cloud service to cloud service within a virtual network can also freely talk amongst themselves. So ultimately, the virtual network is the boundary for communication between all your VMs. Yep. So the cloud service has networking boundaries. So just like you would create subnets today, you would put your cloud services in subnets. Also, the cloud service is the network entry point into your cloud. So for example, over there I have cloud service that could be foo.cloudapp.net. That's the public entry point. And then if I open a port like port 80, then somebody could browse to foo.cloudapp.net and access that VM that I've mapped that entry point to. So if I stand up AD in a separate cloud service, I could turn on no entry points to protect that cloud service even further from anybody even being able to access it, right? So it kind of sets up boundaries within your application. And then when you have virtual networks, you can connect virtual networks in the cloud to real physical networks on-premise through VPN. And the VPN tunnel is a level 2 network security tunnel through a Cisco or Juniper router are the two that we support today. But that really gives you full access to your network over the internet. The other piece that's interesting here is that the top one is whenever you create a virtual machine, you get a random entry point for RDP, so that every virtual machine you create has a endpoint created for it to RDP, which enables you to RDP into that virtual machine. And if you open up others, like port 80 in this scenario, and if I create two endpoints that have the same port number, Azure automatically creates those as a load balance set. So it'll treat that as load balance traffic round robin to those virtual machines, which you'll see later is the scenario that we want for our web front ends. So in a dev environment, we have virtual machines that we're running on premise in a dev environment. And now we want to run those virtual machines in the cloud. All we need to do is copy those files from our on-disk file system, our hard drive, to Windows Azure storage using a tool called CS Upload. CS Upload is a command line tool that's provided as part of the Azure SDK. And CS Upload does a couple of things. It converts your dynamic VHD to a fixed VHD, and it also does multi-threaded efficient uploading. So it'll retry, it'll copy in multiple threads, and it'll handle all of those sort of networking issues. Kind of think of it as robocopy for Azure, right? So once we copy those files up into our Azure storage, CS Upload does one more thing for us. And depending on which command we run, it'll do one of two things. It'll either create a disk or it'll create an image. Either a disk or an image will be created. And the only difference between a disk and an image is just metadata stored in Windows Azure that points to a VHD file. And the only difference between the two is one is assumed to have sysprep run, images, and one is assumed to not have sysprep run, disks. So in this scenario, if we're just copying a farm that we've already have provisioned, then we want to have disks created for us because these images can't be sysprepped, so they're just disks. Once we have the disk in Azure storage, we can then create virtual machines from those disks.
The alarm you heard was caused by a minor incident. The situation has been taken care of. We apologize for any inconvenience. Thank you.
Okay. So, as you know, you can't, or it's highly recommended that you don't sysprep your SharePoint farm. But what you can do is you can install the prereqs, install SharePoint, but stop short of running the config wizard or psconfig. And at that point, you can sysprep that machine. And when you sysprep that machine, you can then copy that machine up as an image and use that to create lots of instances from that image. So that's one thing. The other kind of tip here is stopping the VM doesn't stop the billing. And this one is probably the most important one as a developer, and especially if you have a small MSDN account, this is really important. Now, what you have to do to stop billing is to delete the virtual machine. But deleting the virtual machine doesn't mean deleting the VHD file. You're just deleting that compute part of the machine. And there's actually a script as part of the PowerShell script to allow you to export cloud services. And what it does is it goes down through your cloud service, copying the configuration information of all the virtual machines and saves that as an XML file on your computer, and then deletes all the virtual machines. Then, so say you do that on Friday when you go home, you come to work on Monday, you can run import, point at that XML file, and rehydrate your development environment again for work. So that's the way that you stop virtual machines, and it's important that you use those techniques to turn off farms or delete farms. Because one of the things I always say is that even though Windows Azure is infinitely scalable, a lot of times your credit card is not. So make sure you turn those off. There's other tips and techniques that we can use, and a lot of these go to how automated you want a system to be. We have a lot of teams in Microsoft creating scripts that automate a lot of the process. from beginning to end. And one of the techniques they use, which is very interesting, is that they turn on remote PowerShell using group policy. So that when they stand up the first AD machine in their dev farm, group policy will be enabled so that when I add the machine to the domain, that machine will have group policy turned on. Which is important because after I install the virtual machine, I still need to provision and build SharePoint farms. And in order to do that from my desktop, I need to turn on remote PowerShell. And so for my commands to continue, I'll just use remote PowerShell to do that. Another one is this one kind of is part of the import-export tip, which is there's a PowerShell command which is remove Azure deployment. And a lot of times, if you've actually tried this, you go into Windows Azure, you ran this script, and it created a whole bunch of virtual machines in a cloud service, and now you want to delete it. So you go and you delete the virtual machine, and then all the virtual machines start to kind of re-provision. And then that takes 5 or 10 minutes, then that's done. Then you can go delete the second one, and then all the machines kind of re-provision, then you delete, and it takes a long time. If you run this command, this basically blows away all the virtual machines in just a few seconds without going through that process that you go through in the portal. So as a developer, the portal experience is probably not the best for building farms and tearing them down and building them and tearing them down. That PowerShell is really your friend. How many people are PowerShell experts here? Run, don't walk, and buy a book, because it's super important in this model. We're actually building. So the hands-on labs, if you're not aware, the hands-on labs for the conference, we built on Windows Azure. And so they're all running on Windows Azure today. We actually have 1,800 virtual machines running. Can we turn the volume down in the back? We still have our sound guy. So we have actually 1,800 virtual machines running on 14,000 cores across multiple data centers around the world to run the hands-on labs. And we do all of that through automation. We bring up the farms, we tear down the farms, we provision the farms, all through automation. So it's an amazing thing what you can do, and you can see some of the scale that we're reaching by going down and doing the hands-on lab. So just as a reference, you can find this information. The best place for PowerShell information is the guy who originally wrote PowerShell, which is Michael Washam, who's a colleague of mine that we work together. But on his blog, if you go look on his blog, this is an example he has, and this is how easy it is to do the import and export script. So you just need these, basically 2 lines of code to make sure you run this and save your wallet a bunch of money. All right, so let's take a quick look here at how we do some of this. One of the things I want to show you real quick here, because it takes a little while. Let's do this one. So when you run CS upload, in this case I have a developer farm that we're running CS upload on, and this is I have a bunch of batch files that I run because I have a farm that has domain controller, a farm. Sorry, I'm going to do this other one here. Let's get rid of that one. And I recorded this because it takes obviously a while to copy 4 30-gigabyte files up into Windows Azure. So I'll show you what this looks like here. So basically I have these 3 files which are part of the VHD set. If you remember, there was the information worker VHD set that you could download for 2010. This is that equivalent for SharePoint 2013. I have the domain controller, I have an SP machine, and I have a WAC server or a Windows application server. Now, running CS upload is fairly straightforward. Basically, I specify the destination, which is where I want to copy the file to in Windows Azure storage. The next piece is the path where the file is on my physical machine. And then I can specify some metadata, you know, the config and description and label, and does it have an operating system, and so on and so forth. But the important thing is the first parameter, which is add disk. Add disk will copy the VHD file up into the system and then make a disk out of it. The other command is add persistent VM, and that will make an image out of it. Other than that, all the parameters stay the same. So once you have this one set up like this, just change that first parameter, and you create disks or images depending on which type of system you have. But this is really all that it takes. Obviously, the first part is the subscription information. You download the management cert from your subscription, install it into your local cert store, get the thumbprint from that, and then you know, once you have the thumbprint here, you can do all the management stuff. So that's how easy it is. Now what happens is when the script runs, what we'll see here is we'll see that we're copying the VHD file up into Windows Azure Storage. Now I have a pretty good bandwidth that I was using. So that wasn't actually my bandwidth to Windows Azure. What happens first is it does the initial step where it converts it to a fixed disk, and that was the bandwidth to my SSD drive on my laptop, and so that I got pretty good throughput there. But once that's running, you can see I can kick off a bunch of them at the same time. Once it's running, let's see, one is finished here. So what we can see here is on this one down here that finished, we can see the time and how long it took to copy that VHD file up. And it's actually not too bad, right? It took 20 minutes to copy the file, and you know, the throughput was pretty good. So it's not a short period of time, but it's not forever either, because it does a lot of smart things. It does multi-threaded. It only copies the bits. So as Corey mentioned before, if you store files in Windows Azure, it only charges you for the bits you're using. So even though you have a VHD file that you're using 30 gigabytes of the VHD file, but what's the default size of a VHD file if you create it without specifying? 127 gig, right? So it converts it to a 127 gig fixed disk file, but you're only using 30, and it copies it up. Well, it doesn't copy a 127 gig file. It only copies the 30 bits you're actually using. And Windows Storage doesn't charge you for a 127 gigabit file, even though that's what it says. It only charges you for the 30 that you're actually using. So that's how it gets some efficiency in doing that. And then what happens is once that's done, we can actually see these files in Windows Azure Storage. So let me get out of this and go to here. And we can see that we have these files here in Windows Azure Storage. So here are the 3 files that I copied. And what's great about Windows Azure Storage is once I copy those files up, I can then easily make more copies, you know, after I do it. So if I copy them up, I can come in here, and this is a free tool I'm using called Cloud Explorer. I can create a new folder called, you know, backup. And then I can just say, well, I want to copy, you know, this file. You can see it says it's 127 gigabytes, but it's not really, right? It's just much smaller. But if I copy this, come to my backup folder and do a paste, I just copied that 30 gigabyte file just in a couple of seconds. Because Windows Azure does a copy on write, so you know, it's very smart about that storage. But what I have now is I now have clean copies of those files I uploaded into Windows Azure Storage. So really what I'm saying is you only need to use CS Upload once. And once you get a clean copy up into Azure, then you can just make a backup copy and, you know, create VMs, do your tests, and then delete those files and recopy them again and reuse them. So, yeah. Yes, you're charged for storage, but storage is dirt cheap. I'll show you when we get to the cost section. Relative to everything else, storage is free. It's not free, but it's super cheap when you look at what you're getting for that storage. Because when you get this storage here, you're actually getting 6 copies, right? You're getting 3 in the local data center and 3 more shadow copies in another data center 500 miles away. So you're getting 6 copies of that file for you in a very redundant fashion. But what happens is once we have those files uploaded, we can then create virtual machines from those files. So what I've done here was I've created, you can see I have a cloud service, and this is that farm. I'm using 9 cores for those images. I can see here I'm only running the SharePoint machine and the domain controller. If I want to, I could come in here and connect to that SharePoint farm. So I'll just RDP to that farm. If I can remember. It's really weird. Let's try it again. Okay. So I should be able to RDP to that farm. I'll show you another one in a little bit. But what I can do here, now let's say I want to add the WAC server to that. I just come here and say new virtual machine from gallery. And these are the images that are available from SharePoint, like available from Windows Azure. Microsoft provides these images for you. But I can also see the images and disks that I uploaded. So the ones that were created by the CS upload. So what I see here is I can see, here's that WAC file that I uploaded using CS upload. That's here, available for me. So if I come here and run this, we can give it a name like SB15 WAC. Choose the size machine that you want it to be. Give it a DNS name, or in this case, I don't want to use an existing, I don't want to create a new cloud service, I want to add it to an existing one. So this is a little bit confusing, but this is where you add it to the other machines. So here's where I say, hey, no, this one belongs to these cloud services, and then now it turns everything else off. You can choose the availability set, and away you go. And we can see this one is provisioning now, and it's going to be provisioned into that cloud service that we just created, and then we'd have our web application server up and running. Let's see if we can see this here. So we'll see that in a little bit when it comes back online. All right, let's flip back. So that's dev and test farms. But in production farms, we're going to have a little bit more complicated scenario. And once you start standing up production farms, it is important to understand, and really this diagram becomes the blueprint or the starting point for where you start your farm. So start with this as your diagram of how you build things. You create a virtual network, and then within that virtual network, the first thing you want to do is create a cloud service for your Active Directory servers. Once you have the Active Directory servers up and running, you can then create a cloud service and stand up SQL Server. Once you have your SQL Server stood up, you can then install SharePoint for your application servers, central admin, and then you can add a number of web front ends. Once you have the web front ends stood up, then you can add the endpoints. So I can add port 80 and port 443 to my web front ends, and I can add port 2013 or whatever you specified for the central admin port for your central admin machines. Now, then what I could also do if I wanted to, I could connect that network together with an on-premise network using the VPN tunnel so that I can then access things like synchronize with Active Directory or access applications that are running on-premise. But you may also have this scenario, and Corey alluded to this a little bit in his last talk, but you know, the difference between go back one, go back one. Guess we're not going back. The previous one, we had endpoints turned on. This one is exactly the same scenario, but there are no endpoints turned on. And in fact, this is the way we run a lot of our internal Microsoft SharePoint farms for the things that we're doing internally. This is basically a intranet hosted in the cloud, if you will, right? All we've done is we just didn't turn on any public endpoints for our virtual network so that you can't access that externally. But we have full access from internal users going out to that farm. Yeah. Yeah, so could you do both, which was really this diagram. Oops, where are we at here? This diagram was really both, right? In this particular diagram, it's really both. Like, people could come in through the tunnel, or they could come in through the load-balanced endpoint way, either one. This scenario is interesting because we have a lot of people still, cautious about the cloud. They say, well, I want to stand up SharePoint, but I don't want anybody to have access to it, right? So this way allows only corporate users to come through the VPN tunnel to access that cloud. But one caveat with this is that in the last scenario, Azure was providing the load balancing services for us. In this case, you have to provide the load balancer because there is no load balancer inside of Azure. So you have to provide a load balancer on premise to load balance across your web front ends in this scenario. Yeah. So the question is, are those VMs, or are they Windows Azure SQL databases? So they're VMs. So SharePoint is not compatible with Windows Azure SQL databases, the service formerly known as SQL Azure. So these are full SQL boxes, and then you would do high availability through database mirroring if you're using SQL Server 2008, or you can use the new high availability features of SQL Server 2012 if you're going to use SQL Server 2012 as your database source. Good. Are there any other questions? Yeah, go ahead. Yes. Yes. So the question is, do you have AD on-premise and in the cloud? Is that syncing? The problem is if you only run AD on-premise, the latency just kills SharePoint, because SharePoint is very chatty with AD. And so you really need to have a AD server sitting close to where your SharePoint server is. And so in this case, it's just synchronized with AD on-premise. All right, so let's take a look at what that looks like. So the first one here is if we have our cloud service for our farm, we can see that we have those two cloud services, the farm and the domain controller that we had earlier. So if we drill down into the farm, what we can see here is that this farm is currently using 18 cores. Let me switch over so you can see that. This farm is currently using 18 cores. And we can see the traffic on the farm. We can see information about the endpoint again. We can see information about which things are mapped to which endpoints down here on the right. What else is interesting? We can see the instances that we have available. So again, the instances that we see running in this farm. I can drill down into the app server here. You can see that my central admin machine is an extra large machine. It's using 8 cores. I can see the endpoints that I have mapped to central admin. So I can see that I have, the central admin port is incoming on 2013 and port forwarded to 2013 internally. So you can set those up. And you can see my RDP port here for that machine as well. So if we connect to this machine, let's go ahead and try to connect to this one. So again, just like you would do on-premise, if you were running Hyper-V on-premise, you just simply RDP into this machine. We can see here on this machine I have the SharePoint farm running. Here I have central admin running because this machine is central admin, right? So I'm accessing this machine. We can see one interesting thing here is that if we look at the machine name here that we're on, we can see that this machine name is the name of the VHD file that I'm running. But we also have an alternate name, which is the name of our cloud service. So our cloud service, if you look down here, is SP 2013-farm-cs. And so if I come up here, I can see that this farm has that name of that. So I can access this farm in a couple different ways, through the on-site machine name or through the alternate name. But as you know in SharePoint, to do that, what I need to do is I need to configure the alternate access names. And so I need to make sure that I add that entry point name, in this case it's whatever.cloudapp.net, to my alternate access mapping so that when it comes into SharePoint, SharePoint knows how to deal with it. Now, but what that gives me is that gives me the ability to take this machine name here, and I can actually open a browser window here, and hopefully, if this works, I can. Actually, I don't want to do that one yet. Let's see here. So I can simply browse to that website. And so this is my SharePoint farm running in a virtual machine out in the cloud. And so this is actually set up for anonymous, but if you have your phone or whatever with you and you browse to that site, you'll be able to hit this exact same site too because it's running out on Windows Azure. The other piece to this is since I've opened the port through the endpoint, I can actually still also connect to central admin as well. And so I'm connecting to central admin from my browser to that virtual machine in Windows Azure in the West Coast data center. Yeah. So in this so the question is this load balancer is a specific one. This exact one here is a single machine because I didn't load balance central admin. I could set up central admin and load balance it and do it the same way I do a web front end. Right? There's directions on the internet how to do that. You turn on central admin, then there's a few tweaks to do to have a load balanced central admin farm. Then you could set load balancing up to do that. But what I have done is I've load balanced the web front ends. So if I come to the web front end, let's try to do this again here. If we come to the web front end, we're hitting one of those load balance sets. But the question is, which one? Right? So one of the things that I've done here is, let's go back to here, and let's go to one of the web front ends and actually connect to it. Open up an RDP session to this. So on this web front end, this is number one here. What I've done is I've actually gone here and modified the master page on that web front end to specify, you can see in the highlighted code there, to specify which server is serving up that page. And what that gives me, and this is not supported or recommended, so only do this in your developer machine, is my caveat. So what happens now is if I go to my machine and I hit F12, I can see in the F12 tools which server I'm hitting very easily because I can see that source code. So if I hit F5 here, we see that we've now hit the second machine in the load balance set. So now you can see that I'm load balancing back and forth across the two web front ends. What's that? What was the question? The port number, right. So central admin is only mapped to one machine. I only have one endpoint mapped to port 2013. Here I have two machines mapped to port 80, so Azure says, hey, that must be a load balance set, and then puts them together for me. But this one is actually a unique load balance set because I'm not only load balancing, and I'll show you this real quick here. I'm not only load balancing, I actually created a custom probe. So within Azure, you can actually create custom probes. And a custom probe is basically, normally the load balance says, hey, web server, you alive? Yes. Okay, here's some traffic. A custom probe actually calls a web page, whether that's HTML or ASPX or whatever you want to be, and if the page returns 200, then it'll send traffic. If the page returns anything else, it won't send traffic to that endpoint. So you, in your page, when you create these load balance, these probes, you want to look at things like CPU, disk, utilization, whatever it means for you to be busy, and write that logic in the probe. In this case, I created a probe here on this page that is fairly sophisticated. Let's see if I can open this page. Let's see here. So I created a page in my inet pub. I created a virtual directory under my root here. Am I on the right disk? So I created a virtual directory called health check, and in there I put a page called IAS start. And if we look at this page, it does nothing. But it returns a 200 if the probe calls it. So it returns that custom probe. So here's where you would put your very sophisticated logic to determine what it means for you to be busy. So let's take a look at some of the code that's used to create this. So the first thing here, this is PowerShell code. The PowerShell code is very powerful, and it's a way that you should really learn to write and deal with Windows Azure because it's repeatable. You can put it in source control. You can give it to your friends and family, and they can run it at home or whatever they want to do, right? It's a lot of fun. So PowerShell is the way to do it. But in general, the PowerShell code is fairly straightforward. We do things like specify the location and name that we want to do. We can now specify a virtual network. So remember, the first thing we need to do is create a virtual network so that we can then put all our stuff inside the virtual network. Well, we do that here on this line here. We're saying, hey, I have this file, this XML file, that is my virtual network definition, and I just want to upload that. The virtual network file looks like this. And it's not horribly complicated, but it basically says, hey, I'm going to create a virtual network called SP2013 VNet, and it's going to have this address range. I'm going to create two subnets, 192.168.1 with a 29 subnet, so that gives me two IP addresses. And I'm going to create another one, 192.168.2.0 with a 24 subnet. And if you're not familiar with subnet math, there's lots of calculators online, and you probably need to call your networking friend to write this. But once you have it once, you really never change it. It's basically the same forever as a developer, so we don't need to do that. We can also find this information if we come to our web page, come back here to networks, drill into our virtual network. So here's the virtual network that file I just showed you creates, right? And you can see the machines that are mapped to the things. But I can also do export, and it'll tell me what I want to export, and it'll export that whole thing as an XML file. And then I can take that XML file and tweak it and do whatever I want to, and it gives me the same thing I just showed you. So that's a couple ways to kind of start with that boilerplate XML file. All right, so once we have our virtual network up and running, what we want to do is actually create the domain controller, because this was the second step. And so in order to create the domain controller, what I want to do is specify a location that I want to store the VHD, and then I just specify some parameters. These parameters are the exact same parameters that you filled out in the wizard when you create a new virtual machine. What do you want to call it? What do you want the password to be? How big do you want it to be? Right? These are the same parameters that you would do in the wizard. And then all you have to do is come down here and then just say create. And so this one line of code right here where it says new VM config creates the configuration for that virtual machine. And then once we do that, the last line actually executes and does the work. So this actually creates the virtual machine for that domain controller. And it's as simple as that, which will create the cloud service. So then once that's done, there's a manual step here to go actually run DC promo on that machine, go configure DNS on that machine, get it all set up and running, right? Or you could automate all of that, which is another level of complexity clearly beyond this talk and beyond a lot of what you might want to do. So you have to weigh how automated you want something at the cost of, I could just go do it manually with one click, right? So those are some of the trade-offs. But the last step is to actually now create the farm. Now what we're doing here is we're specifying some information about the farm. Like, in this case, I created a base image for SharePoint already. I went up and created a new virtual machine, installed all the prereqs, installed SharePoint, sysprepped it, and saved it as an image. Now I can just use that image I created and stamp out as many app servers, farms, web front ends as I want to just by running that, and then I don't have to go back and reinstall SharePoint or do whatever I want to. And we can see those images here. So if I actually came here and said, new virtual machine from gallery, I went to images, I can see those images that I created here in the gallery, and I can stamp out lots of instances of them. If we go back and look at my disks, I no longer see that whack disk there that I used because I've used it. Once you use a disk, Azure takes it off the list because you can only use it once as a disk. But images, even though I used it to build the farm, they're still there because I can make copies of them because they're sysprepped. So once I do that, I specify information about that image and then where I want to go. And then I just create lots of them. So here's number 1. Here's number 2. And what's interesting about number 1 here, let's look at this for a second. If I zoom in so you can see this. Maybe that's just too much there. This line of code right here is how I add the custom probe for SharePoint. Now, what's another great feature of PowerShell is that there are things in PowerShell that you can't do yet in the portal. And adding custom probes is one of those things you can't do in the portal. Or you can't even see that this is enabled in the portal. But if you set this up and don't set up the custom probe, you'll wonder why you're not getting traffic to your web front ends. So this here is how I specify the endpoints. As I create the virtual machines, I can specify endpoints and probes all in one swoop with PowerShell. So we just keep doing that over and over again for as many web front ends as you want. Now I can create as many app servers as I want to. In this case, I've commented one out to save some of my cores. But you can create as many as you want, create as many WAX servers as you want, create as many SQL servers as you want. Now, the only interesting thing about the SQL Server image is here, I can actually attach data disks on the fly as well when I create these images. Because with SQL Server, you want to store your database on data disk, not on the OS disk. And then that'll allow you to create up to 16 1 terabyte data disks that you can pool together as a storage pool, or you can RAID 0 together in Windows Server 2008 to make one 16 terabyte disk for your database. And here's how you specify that. So you just I would just add that line 16 times to create 16 data disks attached to my virtual machine. And this code is on my blog, so don't feel overwhelmed. There's a lot of code. I just kind of want you to understand kind of the gist of how this happens so that you can go, when you see it again the next time, you know how to do it. And then finally, this is the exact same command, new Azure Virtual Machine, new Azure VM. The only difference is now you can specify all those virtual machines at one time, and it'll just go off and boom, create everything at once, as opposed to creating it and spinning it up and waiting for that one to finish, and then the next one and the next one and so forth. So I can do it like this, and everything gets created at one time using the PowerShell commands. Yeah? Yeah, so the question is, where do you run this script? So you can run it on your laptop, like I do here for demos. But I would recommend that you create a virtual machine in your subscription and run the script from that virtual machine. One, you don't have to worry about, I can't turn my laptop off because the script's still running. And you can just kick it off on that virtual machine and use that virtual machine as kind of a server jump point out on the cloud. Plus, you get really good bandwidth from that server to the other servers in the data center. So a bunch of those reasons, it's good to have that up there, and it's stable, and I can take my laptop and unplug it and go to lunch or whatever and not have to worry about the script still running and I'm stuck, right? So that's a good tip to do that. So I think that's about all I want to talk about for that for right now. And this is available on my blog. So if you go to my blog, which is, let's see, bring this up here. It's just blogs.mstn.com/bstubs. It's here. It's right here. And there's all the script on how to do everything I showed you how to do, so you can just go download it. Now, again, the next level of kind of sophistication is actually writing all the script to provision the farm once you've got the kind of foundation up and running. And there's code available out there to do it. We're working on some. We just need to figure out how we're going to package it up and distribute it, and then we'll be all set with that. So ping me if you have any of those needs, and we can see if I can get you some of that code. Okay, so the last thing I want to talk about, we have a few more minutes before Bon Jovi starts, so we'll try to go front. How many people are going to be down front in the water? No? It's probably pretty cold. Let's see if we can get this thing to work here. So costing. So this is really great. Your boss says, wonderful. I love it. And then what's the next question he says? How much does it cost? I run a pretty tight data center. I don't think you can beat me on cost. Right? This is kind of what we get, right? So here's an example of a spreadsheet that I put together, and I'll post this on my blog as well. This is a very simple spreadsheet that calculates, for example, if I have a primary web farm on the top, if I have a hot standby farm running as well, and if I have some sort of supporting infrastructure. Maybe I'm running System Center on another virtual machine set. Maybe I have another domain controller. Maybe I'm running Operations Manager or something like that. I may have some additional information that I want to run there. Maybe I'm doing, you can see on the right side there, maybe I'm doing dev and test as well. How many machines do I need for dev and test? How many machines do I need to do a daily build? Right? When you think about a full production-ready SharePoint environment, there are a lot of aspects to it that you need to think about. And Azure makes a great place to do that because these costs aren't static. This is the assumption if I was running this 24 hours a day all month long. A lot of these costs on the side, test farm, standby, supporting, dev builds, those would be transient. So those costs are going to actually be much less. The other thing is that these are all retail pricing. If you're an enterprise or you make some commitments, and it's all detailed on the website, you pay much, much, much less than these prices for this cost. So there's a significant discount for enterprises. There's a significant discount for long-term commitment. Let's say you decide to sign up for 6 months or something like that. Then you get an even bigger discount on top of these. So this theoretically is worst-case scenario pricing on what you're paying. And then on these prices as well, these are retail prices I think I chose. And in preview, while we're in preview, you get a 33% discount anyway. So you'd actually be paying 33% less than this, right, if you were running today until we go to GA. So let's take a look here. I want to show you an example of this spreadsheet. So the first thing is, if we go to, I think I have this running. If we go to Windows Azure, so go to windowsazure.com for those following along at home. And then what we want to do is at the top, you want to click on Pricing. And here they have a pricing calculator that's a lot of fun. All you have to do is slide the little slider around, and it calculates what your costs are. So we're interested in virtual machines. So if you click on the Virtual Machine tab, we can see that we have some information. So let's say I do an extra large virtual machine, and I want 1 extra large virtual machine. So that's going to be $460.80 a month for that one extra large virtual machine running 24 hours a day. Okay? So then all we need to do is take that information and plug it into our spreadsheet. So if we open our spreadsheet here, so if we look at the spreadsheet, which is basically the one that you saw, we can actually go here on the last page. I have some pricing information. And so this pricing information is how I calculate all the values for the spreadsheet. But this pricing chart here, you can see small, medium, and large. So extra large is 92 cents an hour, or it'll be 64 cents today in preview is what you would pay in the bottom there, right? Does everybody see that? That's this price right here. So 64 cents is what you pay today because we're in preview, or you pay something even less than that if you have an EA and all these sort of things. And then 93% is like if you just walk in with your Visa card and sign up, you pay 92 cents. Now, what's interesting is on this spreadsheet here, we can find that information if you want to go look this up later. Here on the pricing calculator, at the bottom under Learn More About Our Pricing, click on that link, and then it has a lot of information here about various pricing. So what we want to do is we want to go down to virtual machines, so cloud services, virtual machines. So here's that same information that I just showed you on that spreadsheet that I copied out of this page and put as a foundation for my spreadsheet calculations. Now, what's interesting here is that there's one other kind of interesting trick here, which is this one here, which is SQL Server, which is kind of strange, right? What's interesting about SQL Server is that when you create a new virtual machine of Windows Server, you don't need a license for Windows Server. The license for Windows Server is part of the runtime cost, part of that 92 cents an hour runtime cost. Now with SQL Server, you can bring your own license for license portability, and I can install SQL Server on a Windows Server virtual machine and bring my license to run that server. Or I can use the built-in SQL Server image, and I don't need a license for SQL Server. I just pay the runtime cost of that SQL Server license as part of the runtime of that virtual machine. Which means that if I want to just run SQL for an hour to do some analysis or calculation, I only have to pay for SQL for an hour. I don't actually have to have a license for SQL for the whole year. I can use short bursts of SQL Server along with short bursts of other virtual machines right within Windows Azure. So the question is, what about SQL requirements for running SharePoint itself? There are really no special things you need to do with SQL other than the normal best practices. We're putting together kind of a guidance cookbook page now out on MSDN and TechNet. But some of the simple things are things that you would expect, right? Don't put the database on the OS disk. You know, spread your databases out. Put them on separate disks. Have those disks be spanned from different storage accounts, right? Turn off read caching. All the basic things that you would do when you stand up SQL Server are kind of generally the same pattern. So with SharePoint, you pay for a SQL license and a SharePoint license when you run SharePoint. That's the way it is today. That doesn't change in the cloud as well. Question in the back? So the question is around, is it on the same disk or not? Yep. Yeah. So internally, the question is, so if I create two VHD files, do I get separate disks? And you do. And the way Windows Azure works is that Windows Azure tries to spread you out across the data center. right? It tries to load balance your data, your activity across the data center to spread people out. So if you're on a neighbor that's busy, Azure will over time move you to other disks around the facility. So the more virtual disks you have, the more spread out you'll be in the data center, and the more spindles you'll actually be using. And so we actually see really, really good throughput as SQL Server runs across the data center. And so, but in general, there's not a lot of like special, you don't have to stand on one leg and hold an arm in the air. It's whatever you're doing with SQL today is basically the way you install and run SQL Server on Windows Azure. Yep. Yeah. Are there any other questions? To be honest, the question is about moving VMware to VHDs. The team's working on it. They've created a tool. I haven't used it myself personally. They say it's really good. So if that's something you want to know more about, ping me and I'll look it up. But it's nothing I've done personally. But I've been told the tool is actually pretty good and they're trying to make it better. So maybe that's something we can talk offline about. Yeah. Yeah, so the question is, do you have a SharePoint license cost? So in Windows Azure is basically the OS is provided for you as part of the platform. And the applications are either bring your own license or use the SQL licensing model. So yes, you have to have your own license of SharePoint, and which license portability most of the time allows you, if you have that license on premise, that same license can be used for the cloud version as well. So the question is, we normally run SQL Server on ginormous machines with trillions of SSD drives and millions of gigabytes of RAM, and that's the way you scale SQL. The cloud's different. The cloud is about spreading out and having lots of SQL databases with lots of content databases spread across. So the mindset is a little bit different. You're not going to build. You probably won't, if you have any size farm at all, you're probably not going to have one SQL box with all of your databases. You're probably going to have 10 SQL boxes with 2 or 3 databases on each one of those SQL machines, right? And you want to spread out and scale out in the cloud, right? Cloud is not about scaling up, usually on a machine. It's about scaling out on commodity hardware. So you probably want to spread out when you think about large-scale farms. It would be the way to do it. What's that? So yeah, the cost will go up, right? But you could spread out on large instances and not extra large, right? So there's some trade-off to what you get when you scale. But still, the cost may still be similar to what you would pay if you had a giant, super fast, SSD version of SQL Server. Now, these machines that we have today these are the size machines we have today. But I would expect these to have more options in the future for running larger kind of special workloads like HPC and those type of things. Was there a question back here? No? Yep. I'm sorry? Diff disk? Yeah, so the question is differential disk. So today we don't support differencing and we don't support snapshotting. But you can, like I showed you, make copies of those VHDs, and so that gives you a kind of poor man's capability to do that. We just don't have an automated way to do that, right? But at any point in time, whether that VM is running or not, you can capture a copy of that disk, right? And then create a new virtual machine based on that disk if you want to. So it's an easy way to grab diffs of disks very fast, yeah. You pay, so is there additional cost for virtual network? You pay for the transaction. There is some minor cost to have the virtual network up. It's very low. And there's transaction costs you pay. So some of the other things that we can see, which kind of brings me to the last point here, let me go back to my page here, is that on my spreadsheet, what I'm showing you, either whether it's in the dev environment or in the production environment, is that I'm showing you the cost of, if we're going to run a web front end, we're going to run 4 web front ends with large instances at 46 cents an hour, it gives me this much, right? These are just the virtual machine runtime costs. There are other costs in here which I haven't included on the spreadsheet, which you could add, and those costs are things like storage cost, right? And so the storage costs, what do we have? We had one 30 gigabyte VHD file. So if we say, well, let me store, I don't know if I can get down to 100 gigabyte. If I store, so here's a terabyte of space for $118 a month, right? So that would totally cover all of your storage costs for all the VHDs that I have in this scenario. But then bandwidth, you have to figure out what's your bandwidth, and then figure out your transaction costs. If you want to go deeper into the full calculator, you can actually figure out your storage costs, how much bandwidth you're going through, if you're using service bus, and any of the other services that you're using. Here's the virtual networking, how long you're connected to the virtual network. So you can go through and find all of the elements that you're using and plug those into your spreadsheet to calculate the costs. But that's sort of the essence of where you begin and where you calculate those costs. Question? So for our scenario, we have no ACS connections. But these are the kind of things like, another hard one to calculate is like transaction costs. As you read and write to the disk, there's costs associated with that. Or bandwidth costs. I mean, some of these are very, you have to just take best guess, and you have to know what your environment is and maybe do some baselining over time to figure out what those costs are going to be. But most of the other costs outside of the running the VM are really pretty low. Like storage costs, transaction costs are fairly low. And so they figure in, but they're not like huge deal breakers at, if we miscalculate how much that storage cost is, right? All right. So in summary, I think especially with the way we're at right now in preview, it's important to start building dev and test environments, right? Start trying these scenarios out. Try figuring out what the best environment for you to run in, what the best configuration is for you to run, how much you're going to have to spread out, what your storage costs are going to be, and then understand and start building those things, right? Looking at all those storage costs, VMs, storage, transactions, licenses, that'll give you a really good ballpark to figure out what the total cost is. There are some resources that are available to you. One of the most important ones is kind of the one I was talking about before, where we're building this Wikipedia, this wiki cookbook style for all the tips and tricks that the SQL team and Azure team have been putting together, and they're on this link here. You could probably just search for SQL Azure Cookbook and find it. And in there it has all the features about how to spread out, what attributes to set, how many disks to do, and those kind of things are all in there with any caveats that they've come across. Some of this stuff is still in flux, so something that's a certain way today may be just a side effect and that may go away. Like you may have to work around it a certain way today, but that's not really what will happen when we go to GA. So just keep that in mind that we're still in preview, so some of this stuff may change. And with that, it's Bon Jovi time. I thank you for your patience. It was very challenging during our fire drill. You guys did extremely well. Please fill out your surveys, and I'll be down front if you have any questions. Also, I'll be in the pavilion in the expo area tomorrow in the morning for a few hours. So if you have questions, stop by the Azure booth and talk to me, and we can drill down into anything you want.